All right. All right, so today's lecture is going to be about classes. Again, we've kind of used classes with our unit test framework, but it still might be a foreign concept to you guys. So the goal of today is to understand classes, why we use them, what they offer, and kind of why they're important, I guess, to development. So the title of my presentation is Making Your Code Classy. All right, so to start, I'm actually going to talk about the goals of a software developer. So all of you guys, I assume, eventually want to become software developers. So it's good to kind of have that understanding. This isn't anything revolutionary here, but I kind of want to just go over it. So the first part is, I guess there's two parts to it. One is solving a problem, and then solving it well is the second step. So I guess the main point of takeaway here is you shouldn't be just satisfied when you solve a problem and be like, all right, I'm done. I passed all the test cases. What do I move on to? There's also that added notion of, all right, you solved it, but now how can you make it better? There are many ways, many things that go into having good software, good software code. It's not simply just, solving a problem and thinking you're done with it. So yeah, I would say, step one and step two, this is kind of what separates a good software developer from any old software developer out there. So when we talk about solving a problem well, there are many, I guess, facets to it. The three buckets I would break that down to is one, structurally, you can make your code better. This is better design. And I'd say this bucket is primarily for the developer side, as in your end user probably won't notice, if you've commented your code correctly or if you're using proper classes, as we'll talk about today, or your end user is not going to really notice how you design your code as long as it works and gives them the result that they're expecting. The next way you can make your software solutions better is functionally, and this is more user oriented as your client. Do they notice, does it perform well? Does it have a lot of features? Does it is it easy to use? That's a key aspect. A lot of functionally design code is intuitive, as in when you think about user UI UX design, user interface, user design. It comes into play where your users will notice if you've not designed your code correctly from the UI standpoint. So that's how you can make your code better from a functionally standpoint. The last bucket is algorithmically. This is when efficiency comes into play. Does your balanced parentheses solution take an hour to run? It may deliver the correct result, but if it takes an hour to run for a normal test case, then there's probably something that you can improve with your algorithm there. So so these are the three main buckets. There's a lot to talk about in all of these buckets, so I'm not going to dive too deep into them. The one I'll kind of highlight is structurally, because that's kind of what our lecture today kind of focuses on. So let's talk about improving your code structurally. There's many aspects to how you can improve your code structurally. These are just a few bullet points I have here. There's more to it. But the first bullet point is code organization. So this, again, it impacts your development. It doesn't really impact your end user. But how is your code organized? Is it kind of just like one large function, or is it kind of broken up into smaller modules, sensible modules? Are you using functions, or are you kind of just writing one entire solution in one file? Other aspects that can improve your code, use it for larger projects, is your system architecture. So this comes into play, like how's your entire software solution designed? Is it like a client server model? Is it peer-to-peer? Like those design decisions that you make up front can impact how well your code is maintained and how it operates. Future-proofing, this one's definitely tough for any software developer. When you're creating like a project for your job, you always want to be mindful of what could change for the future. Again, it's hard to predict fully, but you kind of predict like, okay, I have 100 users right now. Can my software solution work for 1,000 users or 10,000 users if that scales in the future, right? You could also try to anticipate like future feature requests that may be requested, like for balanced parentheses, for example. We handle a case where we have only curved parentheses, but what if we had square brackets and curly braces? Like what if our request changed that we need to match all types of parentheses or brackets? Could our solution that we coded up earlier handle that, or would we need to make changes or like restructure the whole thing? So that's always something to keep in mind. Like your requests might change, so you kind of anticipate them. Again, you can't fully know what the future will ask for, but you could also always be mindful and kind of think about possibilities and kind of create your code in a manner that can scale for the future if needed. Reliability and readability. These are a little more straightforward. Reliability, that comes into, we've been doing testing. Testing's a huge thing about how reliable is your code. Does it actually give you results that you expect? Also, reliability goes into, how safe is your code? Does your application crash if you get the wrong input? We had a student ask for balanced parentheses. What happens if you get an integer input? How would you handle that? So yeah, currently, if our balanced parentheses solution did not get an integer or did not get a string, we would probably not produce the right result, or bad things might happen. So that's something we could definitely improve with our balanced parentheses solution. But yeah, that's where reliability comes into play. Just like how safe is your code, how protected is the end user from using your code. Readability, that's again things we've covered before, but things like commenting your code, again, might seem kind of minor, but when you get into the software industry, a lot of times you're not just going to be working on your own code. You're going to be interacting with the team and working on the code together. So when you're coding up something, adding comments can save another developer a lot of time when they get to a block of code that you wrote. If you comment it correctly, they shouldn't have like too many questions about what your algorithm's doing or what your solution's doing. It should be pretty clear through comments, and good. Another thing, like good variable naming. As you saw in balanced parentheses, I kind of had some questionable variable names. Like I had one variable called balanced paren string and then a balanced paren string official or something like that. So maybe that's not the best naming. So hopefully I'm not setting a bad example there. But yeah, you want your variable names to be descriptive, so it's obvious what they're doing, what types they are. Commenting, also like good function names. Readability, again, it may seem kind of trivial, but it is a very important thing for improving your code. Just having it be, I guess, readable and understandable by both yourself. Like if you come back to your code a year later, it should be pretty easy for you to understand it, but also more importantly for your teammates to be able to look at your code and understand it. Another key fact there, or key feature there, as we've talked about last week, was are you adhering to coding styles? With Python, we use snake case. You may say like, well, I don't like underscores. Like, why do I use them? But it's just an agreed upon, I guess, format that it makes it easier to work with code and deal with someone else's code also if we're all using the same formatting and coding style. So that's just again pretty high level, but ways to improve your code. There's many ways you go about it. So make sure you're being mindful of not just settling for one solution, but think about how you can improve your code in these aspects and other aspects, as we highlighted with like algorithmically. If your algorithm is taking too long, look for optimizations. That's a whole nother topic. We'll maybe cover that later in a later day, but yeah, just be mindful of it, I guess is a takeaway here. So let's talk about programming paradigms. There are many popular paradigms. Some of this comes down to what you're trying to accomplish. One paradigm might make sense in one solution, but not in every other case. You might have heard the term object-oriented programming, also short form OOP. That's a popular term you'll hear, especially these days. It's a popular programming paradigm. And a lot of the reason it is popular is because it kind of just makes sense for real world situations. But there are other programming paradigms out there. Functional programming is very popular. There's other procedural programming, structured programming, logical programming. Again, these are just titles. I'm going to be honest, I don't know what the details of all these, but they do exist. So if you're curious about other programming paradigms, you could definitely Google them and see kind of how they differ, when you might use one over the other. That's something that it's good to know about. So object-oriented programming isn't something that you'll always use. Again, it just depends on your use case and what I guess your software needs to do. You shouldn't always just say, okay, I need to do object-oriented programming because that's what everyone does. But it's something that is used widely throughout the industry. So that's what we're going to be covering today. All right, let's move on. So here at Code Platoon, we're not too focused on getting you guys too deep into the theory. Our process is to kind of give you hands-on experience, kind of get you coding more than just reading, documentation and textbooks over and over. We want you guys to learn through experience. So we don't usually bother too much with the theory, the fundamentals, but it is good to know about them. So when I get into the fundamentals of OOP, it's more for your benefit, just because I think these are popular interview questions, so they're good to know about and good to research if you're preparing for an interview. I would say, more times than not, if you're dealing with OOP, you're going to be asked maybe about one of these concepts in your interview. I've been asked about them. It's just good to brush up upon them before interviews. So just to go over them quickly, there are, I guess, 4 main pillars of object-oriented programming, or features of object-oriented programming that are listed here. So one, we have inheritance. So this is the idea of kind of sharing similar features and not repeating yourself. You don't want to, if you catch yourself writing the same code over and over again, that's probably something that could be improved in your code. There's a notion called the DRY principle, DRY, which stands for don't repeat yourself. And that's, again, very important for just keeping your code, I guess, condensed and not I guess, doing the same thing over and over again, because that's inefficient both from your personal developer standpoint and also in your solutions. What I mean by that is, if you have repeated code like in 3 different places that's doing the same thing, if you need to modify one place, then you're gonna have to go through your entire code and modify all other places, right? You want to have a single, I guess it's called the single responsibility, where only one piece of your code is solely responsible for one aspect, like an algorithm, computing something, or whatever it may be. So the next, I guess, feature is called polymorphism. And these are kind of like fancy words, which I'm not a fan of. Like, they sound fancy, but they're actually pretty simple concepts in terms of what they actually mean. So polymorphism is just the concept that objects can kind of take the form as needed, and that kind of makes it flexible, so that, if you call a function that you call a function that can take in either a string or an integer or a boolean and still produce the right result, that kind of just makes your life easier, that you don't have to worry about what type it is, but you get the same output regardless. So polymorphism is kind of built into Python, being a dynamic language. Like, some of it is kind of inherently built in. Other languages, it's easier to see. Python kind of, I guess, hides that away. The third one is abstraction. This is the idea that, we create modules and we kind of bake all the logic into that module, so that anyone external to your module that's using it, like, for example, our balanced parentheses example, if we create that module and like export it and someone else wanted to use that to check their code to see if it's balanced, they don't really need to know how you implemented the balanced parentheses check, so long as it produces the correct result. That's what they're interested in. So that's where you abstract the logic away. So you just call a function called balanced parentheses. It returns a string that's balanced. How it does that, we don't need to worry about in terms of if we're a user of that module. So again, that's where abstraction is this idea. We hide away the complexity and kind of just give them an interface to get the data that they need. Encapsulation is the idea that we kind of hide data and only provide, I guess, an interface that is required, but we don't provide necessarily an interface to all the data or expose all the data to an external user. So again, this is a little harder to see in Python because Python doesn't really have a notion of data hiding. Other languages like C++ has a concept of private members and public members. So private members are ones that aren't exposed to, I guess, the outside for anyone using the module. Public members are the ones that are exposed, whether it be data or functions. And we'll talk more about what classes are shaped like. But yeah, so a simple example of encapsulation is, suppose we had an idea of a person, and the person has like, a name, which, generally is public. But we also have things like maybe social security number that we might be storing in a person module. We wouldn't necessarily want to expose the social security number just, to anyone using our module, because that's, usually private information. So the idea of encapsulation would be, how can you hide that so that you still have the social security number in case you need to use it for something like, verifying I don't know, whatever it may be, something against a government database, you might need that social security number present, but you may not want, anyone just using that personal module to say, hey, what's your social security number? And then they could, just extract that away and use it for harm potentially. So that's the idea of encapsulation, just exposing what you need to and then hiding what you need to. And again, this is a little harder in Python because Python doesn't have a notion of private and public numbers, but it is, I guess, a core principle of object-oriented programming. All right, so again, these are just 4 buzzwords. You'll probably see them again in terms of if you're applying for OOP positions or if you're studying more about object-oriented programming, you're gonna see these words pop up. So I just kind of wanted to highlight them. Again, don't worry about memorizing what they do or seeing examples of them. We'll talk more about inheritance in a later lecture. So we're not gonna do a deep dive into all 4 of these, but I think inheritance is definitely important, and we will cover that in detail in a future lecture. All right, so that's all the boring theory stuff. Hopefully you guys are familiar with these concepts eventually, but yeah, don't worry too much about those right now. They don't really impact our lecture today, which is gonna be about just introducing classes to you guys. All right, so moving on. Let's talk about classes, because that's the main focal point here. What are classes? That's probably #1 question you guys have if you guys haven't seen them before. Yeah, so classes are user-defined types. And so if you may or may not know it, but you've actually been working with classes already in Python. Everything is a class. If you think about like the string class, you guys have used strings for your coding challenges. Strings are actually classes. When you create a string, you're creating an instance of a class, and that gives you, the string class gives you a bunch of methods that you probably use. For example, if you use like capitalize or to uppercase or to lowercase, those are pre-built methods in the string class. So you're using methods that work with a class that manipulate the data and give you something back from it. So yeah, so classes, again, you've been using them. Maybe you didn't even know they're classes, but yeah, everything for the most part that you've been using are classes in Python. So classes offer a way to create user-defined types also. So you can create your own class, especially when you get into more complex solutions. Yeah, just having strings and integers and booleans and even like lists and dictionaries, like that won't cut it necessarily. You're gonna have to combine them and create, I guess, larger and more complex data types. And that's where you create your own user class and kind of bundle that together so that you offer like a, for example, if you want a string that's always uppercase, you might have a string class and have special functionality that always makes it uppercase. So that'd be your personal defined string class, for example. Why do we use classes? The reason for classes is to combine data and ways to manipulate that data all into one package. Again, you're encapsulating it. That's one of the buzzwords that we used before. So you don't want to have this code like all over the place that works together. Like that is a solution, but that usually isn't a good solution. As we talked about earlier, improving your code using classes is just to, again, have that single responsibility mechanism where your class does everything it needs to with the data it's holding, and you don't need to rely on something external to work with that data. So classes tightly bind data and data manipulation methods together. Again, we'll see an example of this, so if that's kind of confusing, it'll definitely make more sense once we go through some code. The reason why, I guess, object-oriented programming kind of just makes sense is because it's really useful for mapping real-world situations. Classes usually, I guess, objects map to real-world things. For example, again, if we're creating a personal class, a person might have a name, might have like a height, a weight, social security number, whatever you want to keep track of. Like you would just create a class for a person and keep those data members in there, which kind of makes sense because like I as a person have a name, have a height, have a weight. So it makes sense to kind of map me as an individual in the real world as an object, I guess, in the virtual world when you're coding. So a class on a high level just represents a concept. So if you think of a concept of like a fruit or a person or a car, like when you think of those things, that's just a concept. You're not thinking of necessarily a particular person or a particular car. It's just kind of a blueprint or an idea of what the object is. But then from those concepts, which are classes, we create instances or objects from them. So that's where, when you think of an idea of a car, you usually think, yeah, 4 wheels, has doors, has a steering wheel. But then when you actually create an object or instance of it, you're like, okay, I'm thinking of like my car that I own that's sitting in my driveway, like that minivan that we have for our family. Like that's an object, that's an instance of the car class, if that makes sense. So that's kind of how what classes are used for. Again, just to tightly bind data together and the methods that work on them. And then they're blueprints for creating objects in your code as you need them. All right, so let's actually look at how to actually create a class in Python. The syntax is pretty simple. All you got to use is the class keyword, and then you got to name your class. So the style that Python uses is actually camel case. So again, if you're tired of using underscores, this is a case where we can use camel case. We usually use capital letters and for each word, and you just give your class a name. Again, you want to be descriptive. Make sure your class has a sensible name. You just don't want to call it, blah, if it actually represents something real. The two main components of a class are attributes, which is the data that your class is holding, and the methods. Methods are simply functions that work upon your data, whether it modifies the data or just returns it, or even like sets it within your class. That's what methods are. That's another name for functions within a class. So yeah, again, it's pretty straightforward there. You use the class keyword, give your class a name, have that colon, which I always seem to forget when I'm typing, and then you add attributes and methods as needed to your class. All right, so that's kind of how you create a class. Let's actually see an example, because I think talking about it doesn't really do much for me. I like seeing examples. So I'm going to go to my coding window, which has disappeared. Sorry about that. Let me pull that up. There it is. All right, so here's my coding window. Let me create a file. I'm going to call it classes.py. And yeah, let's get coding, I guess. One moment while I pick this up. All right, so let's talk about classes. I'm going to create a dog class. So to do this, I will use the class keyword that we just talked about, and Visual Studio kind of highlights keywords for me in Python files, so I know that's a reserved keyword. And then I'm going to call my class dog. So the format here is, again, class, give your class a name, and then use the colon. You could also have derived from a class, which we'll get into, but that's what parentheses. So these parentheses are optional. If you don't derive from any other class, you could leave them off. This is different than functions. Functions always, if you're creating a function, my function, you always got to have those parentheses there. So though for functions, parentheses are required, but for classes, you can leave them off if there's no parameters going into them. All right, so that's class. The first method I'm going to introduce is a special one. It's called init. So this is a special reserved class name, and I'm going to use TF because it's a function. All right, so init is a special reserved function for classes. All your classes will have access to this method if you need it. This will take in a parameter of self, and I'll talk more about the self parameter, but for the most part, every method that you have in your class will take in a parameter of self. This can actually be named anything you want. I can name it whatever, but going back to just coding conventions, Python community has agreed on the keyword self, so if you don't want to upset anyone, I would say adhere to those conventions and use the word self here. And then you can pass in parameters. So let's say if I wanted to give my dog a name, I'd pass in the name value. And then let's see how we actually use the self parameter. So self is this first parameter is actually a reference to an instance of a dog class. So if I want to set the name here, I'm going to do something like this. So just to explain this a little further, we have an init class. This is short for like initialize. This is the first function that will automatically be called when an instance of your class is created. So to give this a better example, let's actually create an instance of this class. So let's just call my dog Fido, or my variable Fido. To create an instance, I'm going to use the name of the class, which in this case is dog, and then it takes in one parameter. So the self parameter is actually automatic. You don't have to pass it in yourself. So I can kind of ignore that. So the self is going to automatically be passed through the magic of classes. I just care about one parameter here, so name. I'm going to give my dog a name of Fido. And there we go. So in this case, I've created a blueprint, which is my class here. This is a concept of a dog. But down here on line 7, I'm actually creating an instance of the dog. So these are keywords, terminology to be familiar with. Instance refers to a creation of an actual, dog object in this case. And then concept or blueprint is the dog class. So, hopefully that makes sense in the sense, we have an idea of what a dog is, and then we actually can picture a dog. Like if we have a dog as a pet, I know many of the students I talk to do have pets. So, when you think of Fido, that's an actual dog, living dog that you can think of versus just thinking about the idea of a dog here. All right, so that's a very simple class we created. Again, the init method will be automatically called, so we're not calling init here. When you create a dog object, this init function will automatically be invoked. So let's say I wanted to see what Fido's name is. I could do a simple print statement, Fido.name. So I have access to this name member because everything in my class is public. So the self.name created a name attribute, and then I'm accessing this attribute on line 8. So if I ran this, let's make sure we're in the right folder. And let's give that a run. Python classes. All right, so I printed out my name, which is my dog's name, Fido, by accessing the name attribute that I created on line 4 in my class. All right, one thing I'm gonna, bring up here is about code organization. So as we talked about earlier, it's usually bad practice to just have one giant function or one giant file that has all your logic in it. That's not very modular, and it can make it kind of hard to navigate. So in this case, I'm actually going to create some additional files just to organize my data a little better. There's no hard and fast rule, but usually it's recommended for each class you create, you want to put that into a separate file. Now that's not necessarily always true. Like if you have related classes, it might make sense to keep them in the same file. But usually you want to create a new file. So I'm going to create a dog.py file. And I'm actually going to put that into a folder called animals, just for future planning. I'm going to move my dog.py file into that folder called animals that I just created. And then my main file is classes.py. So I'm going to copy my dog class into that file. All right, just moved it over. But now my classes.py file has no idea of this dog class. As you can see, it's underlined in red. If I ran my file right now, it's going to complain, dog is not defined because we have not told my classes file what dog actually means. So to do that, we need to import this dog class. To do that in Python, we say from, and then we give the module name. So in this case, this folder that I created is part of the module name. So I'm going to do animals dot and then dog, which is the name of my file. So that's my module. And then from that, I want to import something. So in this case, I only have one class in there. So I'm just going to call it, I'm going to import dog from dog. That's what I named it. If I had multiple classes in here, for example, class puppy. And I'm going to put the pass keyword. If you guys remember that from Friday, pass just tells the compiler that this is a line. So it's not going to complain that this is, there's no definition to this class. Pass just says do nothing. So in this case, if I wanted to import puppy, I'd import puppy up here. All right. So now I could use dog and puppy if I had puppy defined in this file. So if I ran this, should work. Yep, I get Fido again. So again, that's just how you create modules and import them for future use. So get familiar with this mechanic because you're going to be importing modules, creating modules. Often, again, you want to organize your code in a sensible manner. You don't want to have everything bundled into one file when your projects get larger. All right, so let's go back to our dog class. I want to show some more features of classes here. All right, so let's think about the idea of a dog. So when I think about a dog, there's some obvious features that most dogs have, if not all dogs. So one thing, let's keep it basic. Let's say number of eyes. Most dogs have 2 eyes, so I think I could put that there. Legs equal 4. What else? What else do you think of when you think of a dog? Maybe they make a sound. So let's say all dogs say woof.
Tail.
What was that? Tail? Yep. All
Tail.
right. So we have tail. They have one tail. All right. So yeah, these are just basic concepts. Again, I'm just going to keep it simple. There's a lot to a dog. But so I put these as class attributes. These are attributes within my class, but these are class level attributes. So I'm going to distinguish between that shortly. Basically, the values I put here apply to every single dog. They're not unique to one dog. Like, again, for the most part, all dogs have 4 legs, 2 eyes, 1 tail, and they say woof, according to my stereotypes of dogs. So the reason I put these values here is because they apply to all dogs. However, if you notice here, the name value is not in this list. Like, I would not want to put name here. Put a name here. This is essentially saying that all dogs will have the same name, because these are shared attributes for every dog instance that gets created. So if I put name here, it wouldn't really make sense because all dogs don't have the same name. That's the reason I created this self.name, because names are unique to each individual dog. They're not shared attributes for every dog. So down here, we have a instance attribute versus these items are class attributes. So that's a distinction that you guys are going to have to understand. So make sure you guys kind of see the idea behind creating class attributes versus instance attributes. So I could give more, individual attributes. For example, let's say some dogs know tricks, so I might have a list of tricks here, and then I could pass that in. So if I wanted to pass in some tricks, I could pass those in as a list. If I want to name this a little better, I might say tricks list. And then I would assign it down here. If I don't make typos, tricks list. All right, so again, I just created another instance variable and assigned it in my init function. All right, so let's see these values at play. So I'm gonna go back to my classes file. Put that down here. Sorry, I gotta clear my window. I have a lot of open files. All right, so let's just see what Fido has to offer. So Fido, if I print Fido.legs, I would expect to see 4. Let's actually name that so we know what we're printing out. All right, so let's run that. And I get an error because puppy no longer exists. Where did our puppy? Don't worry, we'll get puppies back. Okay, so I got an error here. This was my fault, but it's a good way to show this. So I added a new parameter here. So now I'm expecting a name and a tricks list. But in this case, I've only specified a name. So that's why I got an error saying one required positional argument, tricks list, is missing. One thing I could do to alleviate that is I could pass in a tricks list. So let's say Fido knows how to, I don't know, roll over, and then he can also shake. So if I do this, this should work. All right, Fido has 4 legs. His name is Fido, as I pointed out earlier. Another way to alleviate that, we kind of talked about default parameters and functions. You could do the same thing here, because init is essentially a function. It's just inside a class, so we call it a method. Methods and functions are essentially the same thing. So in this case, if I don't want to specify this, I could just say none as my default value. So in this case, if I don't pass in a tricks list, then it's going to just default to none. All right. So in this case, if I didn't want to pass in tricks, I'll just leave it off, and it should work. That's fine. Basically, Fido knows no tricks right now, so he'll have to pick some up later. All right. So again, back to our class, we have some class attributes and instant attributes. So get familiar with that terminology because it will come up again and again. But let's actually specialize this a little bit. So we have Fido. He's a good dog. But let's also introduce another dog. I'm going to introduce a wounded dog. Sometimes dogs get injured, unfortunately. So wounded dog, this dog's name is going to be Hero. All All right, so wounded dog is a little different. So as we talked about, most dogs have 4 legs, but I've definitely seen some cute videos of dogs that have 3 legs that hop around, manage to figure out how to run and live a full dog life. But sometimes they might just not have all 4 legs for whatever reason. So in this case, wounded dog is going to be a little special. I'm actually going to set his legs count to 3. All right, so we're going to talk about what this is actually doing. So if you notice in my dog class, I have a legs attribute that is set to 4. Now this is shared by all dog instances. So Fido, as you notice, I never set the legs value. Fido just automatically has 4 legs because that's what's the default for the class.
Question, Encore.
Yep.
So if you were to just print Fido, it'll give you an object with all those shared attributes, correct? Or no?
Not quite. That's a good question. So let me print Fido, and then we'll see what is outputted. It's a good question. But so I'm going to have a print Fido here. We'll see what gets outputted when I run my code. All right. Then going back to my wounded dog example, so in this case, my wounded dog hero only has 3 legs. So this is a special case where I've specified the legs value. So this might not be obvious as to what's going on. This might make it seem like I'm modifying this value for all dogs. That is not true. So when I'm creating this variable, when I write this line, I'm actually creating a new value on the wounded dog instance. So this is an instance attribute that I created on the fly. Again, so it's as if I did self.legs and then specified a legs value. But in this case, I didn't pass it into the constructor or the init method. Instead, I'm creating it after I create the dog object. So instead of passing a legs value here, like 3, instead I want to create it after, which is totally valid. Again, this is the same thing as if I create a variable x equals 3, y equals 4. It's the same thing. I'm creating new data, but in this case, I'm creating the data on my instance. All right. So this legs is actually a new value for my dog instance. It's not overriding my class attribute of legs. And to demonstrate that, again, Fido's leg counts being printed up here. I'm going to copy that, and then I'm going to print out wounded dogs. All right. And to prove that I did not overwrite it, let's create one more dog. Let's call the dog Lassie equals dog. I think that's how you spell Lassie. Hopefully I didn't misprint that, and then let's print out the values for Lassie. All right, I think hopefully I have no typos there, but let's give this a run and see what happens. Let's bring up my terminal window a little bit. Right. So if I want to run this, Python classes.py. All right, so I got output. So for Fido, which is the first legs output, I got 4. As you can see, for wounded dog, I set it to 3, and the output there is 3. I created a new dog, Lassie, and used the legs attribute again, and I got 4. So again, I just wanted to show I am not actually overwriting the class value. I'm creating a brand new instance value or attribute for wounded dog. That's special only to wounded dog. These other instances don't know about this legs instance parameter. It's using the class attribute in that case. All right. Another thing that Christian asked about, what happens if I just print out Fido? So that is the 3rd line here. I get this weird looking animals.dog.dog objects. It's not really descriptive, but that's what Python knows about my object. It knows it's a dog object, but otherwise it doesn't know the details, or I guess how to print out those details in this case. So we will resolve that at some point, but if by default, it's going to give you kind of an ugly high-level description of what your object is and I guess what memory location it's located at. So I'm going to actually delete that line, but we'll get back to it. So I'm just going to kind of pause there. I'll let people kind of digest the idea between, I guess, instance attributes versus class attributes.
Is it easy to get confused like when you start adding like a lot to the class? Like,
Yeah, I mean, you always kind of have to know like what what methods and what data your class holds. This is kind of the same as reading up documentation on the string class. Like I don't have all the string methods memorized, so I usually read up documentation. So I guess this is a good point to mention the help or the help function of Python. So actually, let's say I was working on this dog object, but I didn't really know what was in it. You can use the reserved keyword help and then type in your object. So if I do this and give that a run, it's actually going to run like a separate application within Python. So, all right, so I added this help dog call on line 5, and looking at my terminal now, I have a bunch of information. So this is telling me about my dog class. It tells me the required parameters. So in this case, I have a name, and then I could pass in a tricks list also. As you can see, it shows the default value, so it's pretty descriptive here. If I scroll down, it just gives me more details. There's an init method, which we created. But there's also these other methods that we didn't create that kind of are automatic there. If I keep scrolling, it shows me, I guess, my class members. So in this case, I have I is equal 2, like it was 4. So this is a good way, again, if you're working with any class, not even if you didn't create it, if you're working with like a pre-built-in class and you want more information on it, you can use this help function that will kind of just give you details about the class. So again, it can list every method that it has, and usually there should be some descriptions that kind of tell what each method does. Yeah, so this help keyword definitely, this help function definitely make use of it. To get out of this, you got to hit Q, and it gives you back to the terminal, but it still ran my program there. All right, so let's make our dog class a little more exciting. Our dog class isn't really doing much right now. One thing I want to add is a method. So we talked about the init method, which is a default reserved name. So you have to use __ init and another __. And these are called Dunder methods. We're going to talk about that shortly. But again, anytime you see __ methods, they're usually reserved reserved classes. So you have to name it init for it to call this on initialization. If you name it something else, it's not going to work correctly. However, when we create our own methods, we can name them whatever we want, but we still want them to be descriptives. In this case, I'm going to create a speak method that takes in no parameters, but I need to pass in self, and that is my method. In this case, speak is basically just going to print out self.sound. All right, so this is just printing out what the dog says. Again, this self is referencing an attribute, but this is not an instance attribute. This is, in this case, a class attribute. However, if I did have a instance attribute, this would print that out. So if I, let's say, had a method called legs self, I want to capitalize it, and I printed out, number of legs, self.legs. So this is the same case as we showed here. Let me, instead of printing it out, let me call a method, wounded dog.legs. All right, I probably don't want to name it the same as my variable, so let's call it show legs. All right, so I have this new method. Let me get rid of these print statements, just not to clutter. Save that. So again, just to highlight this, I have a self.legs. If I never created an instance attribute of legs, this will default to the legs for my class up here. However, if I do specify an attribute called legs, it's going to override the class value, and it's going to take priority for the instance one that I created. So again, if I ran this, just make sure it works. But I did not want that help method, so let's get rid of that. Bye-bye. Save that, quit this, and run this. All right, yep, I got legs equal 3. So again, it's working the same way as before because I created an instance attribute here in my class, self.legs, which refers to that instance attribute for the wounded dog case, but for Fido, for Lassie, it will default to this because this value does not exist in the instance scope. All right, we could also do the same for functions. We could override functions if you wanted to. Usually not a typical case, but let's have a case here. Let's have a dog named Scooby. All right, so one way we could, let me create a new method actually. I'm gonna get rid of this show legs method because I don't think I'm using it. I'm gonna create a method called fetch. All right, fetch is gonna do something similar. I gotta pass in self, again, which is self is a reference to the instance that is calling this method. So it's a default magical parameter that gets added whenever you call it. You don't have to pass it yourself. So let's have this print out something, think a little more fancy, I guess. We do self.name, format that. Again, just to clarify if you guys aren't familiar with this, if you put an F before your string, that's going to format it so that you could pass in variables. So self.name, fetched. All right, so when I call fetch, it'll print out the statement using the name. Let's save that. And then Fido can go fetch. Fido fetch. Again, this is a method I created, so I'm not passing anything to it because there's nothing that I need to pass into it based on the way I defined it. Clear this and run that. Again, error because this method exists. Not bad there, guys. All right, so I call fetch, and that prints out Fido fetch the ball. All right, so if I have a dog named Scooby, let's say Scooby doesn't really care about fetching. Let's say that's not something he does. I can actually override this method. So the same way that I overrode the legs, I guess not quite the same. So this is an instance method, but I can override that also by doing this. So let's say I have, let's say Scooby does not fetch. I'm going to introduce some new syntax here. Don't freak out if you're totally foreign to it, but I just want to kind of introduce it, but also use it for what I want to do. Print, and let's just say Scooby.name solves a mystery. So Scooby doesn't really fetch. I guess he fetches mysteries instead of a ball. But so just go over this lambda keyword because some of you guys might not have seen that before. This is essentially equivalent to the fat arrow function that you guys have been familiar with in JavaScript. This is just an anonymous function that I'm creating on this line. So it's going to get created here and assigned to my fetch method. But otherwise, it's not going to really exist outside of this scope of this line. I could do this another way. I could create a function here. I could say def, solve mystery, and then have that print this out, and then assign this to .fetch. So I want to do it this way. I could do, copy this over here. So the function needs parentheses, prints out. I guess in this case, it might take a name. So I could do it this way and then assign solve mystery here with a name if I wanted to. But again, this is the same thing. I create a function, assign that function. Actually, I want to assign that function. So this going to, I guess it gets a little confusing. Let me just use my lambda notation. I don't want to get too into the other way. So lambda basically is an anonymous function, takes in 0 parameters, because I'm not passed parameter, and just prints a statement. All right. So I'm assigning this to the fetch method. So I have a default instant method called fetch, but I'm actually overriding it by assigning my own. So if I did it this way, let's do Fido.fetch down here, just to make it clear that I did not override the instance of Fido, and do Scooby.fetch down here. All right, let's give that a run. Hopefully I don't have any typos, fingers crossed. Run that. All right, so as you can see, Fido fetched the ball because my fetch method in my dog class defaults to fetching the ball. But in this case, Scooby is a special dog. He solved the mystery. So when I call fetch on Scooby, since I overrode that method here, I get the output Scooby solved the mystery. So again, this is a slightly different case from before. Instead of overriding a class attribute, I actually overrode an instant attribute with my own value. So that's totally viable also. So Again, you can override things as you need it. Otherwise, you could default back to whatever the class offers in its definition. All right, so that's a little discussion on, again, class attributes, instant attributes, and also how you can specialize it for individual cases. Again, because maybe not all dogs fetch, like Scooby's special dog. He might, again, if I want to specialize a little more, I could say Scooby's sound is, I think his catchphrase is Scooby Dooby Doo. So in this case, this is what we did before. I'm overriding the class attribute. Instead of Scooby saying woof, when I call Scooby.speak, my speak method is going to use sound still, but since I overrode sound, instead of saying woof, Scooby will say Scooby Dooby Doo. Hopefully. Yep.
Encore.
Yep.
Can you create instance attributes?
Yep.
If they're not, okay.
Yep, absolutely. Great question. I'm glad you asked it. So let's say Scooby does other stuff. Scooby, let's say he has favorite foods. I know Scooby loves to eat. So I just can create a brand new instant variable. Again, there's nothing in the class that has favorite food. There's no class attribute. There's nothing that I've defined in the init method. But again, this is just like creating a new variable. You can create a new attribute on a instance if you want. So favorite food, let's say, is, not sure what his favorite food is. Let's say it's hamburgers, maybe. I don't know. I think Scooby eats anything. Let's say his favorite
Scooby snacks.
Scooby snacks.
It's gotta be Scooby snacks.
Sorry, guys. Yes. Thanks for the pair programming up there. Scooby.
People got so offended.
It's with an X, right? X.
Don't disrespect us like that, Ankur.
All right. So yeah, I created a new attribute here, favorite food. And so if I can access that Scooby favorite food and not format favorites. All right. Thanks for the help there. If I print that out, yep, Scooby snacks. All right. But however, if I did not create this, there's no default attribute called favorite food. Unlike sound, which does have a default in the class, like the default is woof for all dogs. If I don't create a favorite food attribute, this is actually going to cause a problem for me, because when I try to access it, I get an attribute error. Dog object has no attribute favorite food. So it's trying to find favorite food in the instance, does not find it. Then it tries to find the favorite food in the class list of attributes and does not find it. So then it says, whoops, you did something wrong. So the difference here is trying to read a value versus you're writing a value so you can create it. So in this case, print is reading the favorite food value, but it can't find it. So we get an error, attribute error in this case. All right, but yeah, great question. I'm glad you asked it, because I don't think I was gonna mention that right here. But yep, you can create attributes as you wish. So some dogs may have additional features, you can create them if they're not generic or typical features. All right, let's digest that for a bit. Maybe take a break. If you guys are hungry, grab some Scooby snacks or human snacks, whatever you might be to your liking. Let's take a 6-minute break. We'll reconvene and I guess finish this lecture, hopefully by 11 o'clock. All right, so let's take a quick break.
Ankur, you want to pause the recording or stop the recording?
Again. Can you guys see my screen, hopefully? All right, so just to recap, we talked about class attributes versus instance attributes. Again, this is an important concept, so kind of just want to review that quickly here. So again, class attributes are values that are universal to all instances. And when I say like all in the sense that you kind of generally expect it, again, might not be true for 100% of the cases, like where we saw with wounded dog. Like, sometimes not all dogs have 4 legs, but it's a general typical case. So that's why we can code it as a class attribute, because it's shared by, if not all, like the most of the dog instances that will be created. And we compare that against instance attributes. Those are attributes that are unique to each individual instance or object that's created from that class. So a good example is like, let's say we're creating a human class, or a dog class. There's a species name that's shared between all humans. We're Homo sapiens. Dogs, I actually don't know the species name for that. Apologize for that. But also like chromosome count, like humans all have 23 chromosomes. Dogs, again, my dog facts aren't well brushed up on, so I don't know how many chromosomes dogs all have. Again, these are typical cases. Again, there are exceptions to this rule. There are some diseases that chromosome count might be a little different. But generally speaking, chromosome count and species name are universal to all humans collectively, and then all dogs collectively. But then we have instant attributes. So name, like we each generally have unique names. I mean, there might be duplicates, but they're unique enough. Age, we all have different ages. We're not all the same age. So those would be instant attributes if I were creating a human class, or I guess a dog class also. All right, so that's just a recap on attributes. Make sure you know the difference, make sure you know how they work. Instant attributes override class attributes. So if you create the same named instant attribute, that'll be preferred over class attributes. All right, let's move on. So I mentioned this earlier. I wasn't trying to glaze over it. I was definitely going to come back to it. But we have something called Dunder methods. So we saw one of them, which was the __ init method. That's one Dunder method. Dunder methods are also called like magic methods. These are pre-built methods that are given to you with the class structure. So let's meet the Dunder methods. Of course, got to make a Dunder Mifflin pun. Office, great show. But yeah, so Dunder methods are special built-in class methods that are offered to us. So this is another reason to use classes. One thing I guess I didn't get too detailed in, a lot of the stuff that we do with classes probably can be done with dictionaries. The reason we prefer classes is because they provide better organization and kind of give us access to these Dunder methods, which is something that dictionaries don't natively offer to us. And also because dictionaries are kind of generic. Like, we could just create a dictionary of type dog, name, give the dog name, give it additional, I guess, key value pairs. But that's not really creating an object in the sense that a dog is a real world thing that's kind of tightly coupled with, legs and eyes. A dog is not just a key value pair, if that makes sense. A dog is like a full object that has attributes to it. So that's why classes, again, better represent real world objects rather than just using dictionaries all over the place. Again, it's possible to use dictionaries to do the same things that we're doing. Like we could even create key value pairs to create functions. Like the key can be a speak key, and then the value of that could be actually a function that we call. That would work, but again, when we want to improve our code, we want to make it more sensible and use classes when we can. All right, so we have some built-in Dunder methods. If you look at the class curriculum page over here, there's a link to talking more about Dunder methods. I gotta find it. I skipped over it. Yeah, right here. So right here, there are Dunder methods you can call. There's this link here that will take you to a new page. And it has a list of a ton of Dunder methods. Again, there's a lot to go over. I'm not going to talk about all of them. But a lot of these things are just normal things that you do with objects, but behind the scenes, a function actually handles it. So if you're interested about learning about all of them, or at least a lot more of them, go to the page, the link from our today's page. All right, so let's go back to our code. Actually, let's quick go here. So some examples, we talked about init. Some other ones that you'll commonly see are the str method, which we'll talk about, the repr, repra method. EQ is a Dunder method that gets called when you try to compare two objects. So if you're trying to see if one dog is equal to another dog, you could implement the EQ feature to say like, okay, if they have the same, same name, or I guess if you want to get more technical, like if you had a DNA attribute and you compare like the DNA of two dogs that you're comparing, if they're the same, you can return true from your EQ. And we can also do add. There's also a dictionary Dunder method. As I said, there's a ton of them. I'm not going to go over them. Honestly, I don't know all of them, but there's a ton of them to meet your needs. So this is why classes are another great reason to be working with. So this goes back to Christian's, I guess, question about what happens if you print out an object. So we did that earlier. So let me delete some of these dogs. Don't worry, they're going to a good place. Let's hang out with Fido. So when we did print Fido, we didn't really get anything too useful, right? Clear this. All right, so when we print Fido, we get animals.dog.dog, which is the module and the class, and then it's an object, and we get some memory space. All right, I mean, that's sort of useful, but not really. So this is where another Dunder method comes into play. So I'm going to define a Dunder method called str, which is you're going to see a lot. So get familiar with it. Basically, this takes in no parameters aside from self, and this is expected to return a string. So I could return an empty string, but that's not very useful. So let's actually return something more informative here. So I'm going to format this. Let's say, let's use our name parameter. Name is a dog who has, let's see, self.legs and self.eyes, and also has a tail. So all right, so it's a little more descriptive. So I put this into my Dunder str method or string method, and I'm returning a string. Again, this is a special method. You got to call it str. You can't name it whatever you want, unfortunately. But in this case, I'm just returning a string. Let's see it in play. Save that. All right, so now I'm not changing anything here. I'm still going to be printing out Fido, but now that I have the str method defined, print will automatically invoke this method and return take what it's returning and print it out. So let's see this in action. All right, so I did a print, and this is much more useful. Fido is a dog who has 4 legs, 2 eyes, 1 tail. All right, good to know more about Fido. So that's a pretty simple Dunder method. Again, takes in no parameters. It just returns a string, whatever we want it to be. So you can format this as you wish. We kind of saw there's a repr, R-E-P-R method. That one's used for, I guess, making more unique strings. I guess I'm not too familiar on the use case of that, but it's basically to represent your objects. You might print out all your values in that string, but for the most part, you'll be dealing with str, so you don't need to worry about the other method too much, but definitely look into it if you're interested. There might be use cases for it, which I'm not going to cover at this point. All right, so that was a pretty simple Dunder method we use. I'm actually going to make our example here a little more complex just to see the power of classes. Now, some of these things we're going to cover more in detail. As I mentioned, inheritance will be one of those topics that we'll have a day dedicated to it. But I kind of want to jazz up our little simulation here. So just to kind of show Dunder methods a little bit more in detail. So I'm actually going to create a new file. Let's call it puppy. So puppies are going to come back. So we have puppy. And then puppies and dogs are pretty related. You know, they have a lot of similarities. So in this case, I'm going to create a class puppy, but I'm actually going to inherit some properties from dog. Again, I'm not going to go too into inheritance today because we're going to go over it tomorrow, but just know the setup here is puppy is inheriting some properties from dog, and but puppy might have a few different attributes. So in this case, I'm going to say its sound is going to be a little different. It's going to say arf instead of woof because of the puppy. So again, this is a very simple class. I'm not going to have an init method because I don't need to initialize anything different for puppy. But I do need to tell this module what the dog is. So I'm going to say from animals.dog import dog. All right, so I have this defined, my puppy class. It's using the dog class as a base. So just terminology here, this is a base class. Dog is a base class for puppy. Puppy is a derived class of the dog class. Other terminology you might hear is this is the parent class, and then puppy is the child class. Just get familiar with that terminology if you hear it. But yeah, let's create a puppy. Our puppy can be named Rover, I guess. I will need to import animals.puppy. Import puppy. All right, so instead of creating a dog, I'll create puppy and name him Rover. All right, so just to see this in play, let's do a Fido.speak, and let's do a Rover.speak. Clear this. Hopefully I have no errors. Let's hit this run. All right, so first output was woof from Fido, and then Rover spoke and said arf. So if you notice, my puppy class is very simple. All I have is sound here. I didn't have to implement a speak method. The reason being, my dog class already has a speak method that uses self.sound. Now, classes are smart enough, again, as we kind of talked about before, since I have a sound declared in my puppy class, it's going to actually prefer to use that because puppy is the actual class that has a sound instead of falling back on the sound for the dog. Again, so there's priority. It's going to take instances take priority, and then it falls back to classes. But also classes can have multiple levels to it. In this case, we have a dog class that has a sound and a puppy class that has a sound. So in this case, Rover is a puppy. So when he calls speak, it invokes the dog method speak, but the self.sound actually goes back to the puppy method because that's I guess the more local attribute because this is a puppy. If this sound was not here, if I did not have it here, it'll fall back to the dog, which is the base class, the dog sound. So that's, again, just something about classes. Again, this is all about inheritance. We'll talk about that more in detail. So if this is kind of confusing, don't worry, we'll double back on it for sure. That's not what I wanted, sound. All right, I'm gonna make this even more complex. Again, hopefully I don't lose you, but I kind of want to just show kind of how you go about doing some stuff. So this is a little, be archaic, but I just want to show this. So I'm actually going to create a class member called puppy class, and the reason will be clear shortly. So default, it's going to be none, so puppy class doesn't exist. But I'm going to actually assign the puppy class here. So puppy class equals puppy. Now it's going to be a little confusing, but in this case, I'm actually assigning a class attribute. Notice I don't have an instance here. I'm actually using the dog class and overriding its puppy class with a value. Not overriding, I'm actually writing a value. So this is not creating like a new class attribute. That class attribute already exists here, puppy class. And I'm actually writing a value to it, and that's actually my actual puppy class here. So hopefully that's clear. In this case, I'm calling dog dot, which is the class. This is not an instance. I don't have Fido, I don't have Rover, I don't have Scooby. This is the generic dog class, and I'm assigning a value to it. I could do the same thing if I wanted to change the dog sound. I could do that too. This will impact every single dog. So if I did bark here, let's say I ran this over here. Now when Fido speaks, he's gonna say bark because I assigned bark here. So the dog class got created. The default was wolf, but then I overrode it with bark. So hopefully there's no issues here. Yep. So Fido is saying bark now because I overrode it for all instances. Again, every dog that is created now will say bark because I've changed the class method or the class attribute. Apologies there. But in this case, I'll leave it as wolf because my main example here is puppy class. And now what am I going to do with this? It's going to get a little complicated, but hopefully you guys can follow along. I'm going to use a new Dunder method, or not new, but one that we haven't talked about called add. So add actually takes in another parameter, and I'm going to call it other. I could name this whatever I want, but to be descriptive, I'm just going to say other dog. All right. And then, so add gets invoked when you use the plus symbol. So let's say return puppy. Again, I'm kind of jumping some steps here, so there might be some questions, but I'll try to answer them as I talk more about this example. Let's not give it a name and no tricks. All right, so in this case, let's see. All right, let's just do this and see what we kind of created here. So just to talk about what I'm doing here, I'm assigning the puppy class to the class attribute puppy class. The reason I can't just simply do puppy here is due to the limitations of Python. Puppy in this context does not exist. The dog class has no idea what a puppy class is, so I can't just assign a puppy class here. I've created a puppy class using the dog class, and then I assign a puppy class now that puppy exists. So in JavaScript, we talk about hoisting, where you can kind of reference something before it's actually been declared or defined. That does not exist in Python. So I need to assign the puppy class after I create it. And I don't want to get into a circular dependency here. Like I can't include puppy here or import puppy here because puppy relies on dog. So puppy is importing dog here. So if I imported puppy here, we're going to get into a circular dependence where dog relies on puppy and puppy relies on dog, and it's just going to be an infinite chain. And that's going to not, good things won't happen in that case. So in that case, I can't import puppy here. So I can't use puppy here. So I default to none. And then at a later point, I double back and actually apply the puppy class. So what I did here is I'm using puppy class as an actual class. Again, that's a variable, but it's a class. It's referencing a class. So I'm creating a new puppy here. So to see this in action, again, this is a complicated example. Hopefully I'm not losing you guys too much, but let's create another dog. Let's call her Fida. Dog named Fida. I don't know if that's an actual name. Let's actually use this now. So instead of creating our new puppy rover, let's create it from adding two dogs together. All right, so I'm using those plus operators. So normally this plus operator isn't defined for dog. Like Python doesn't magically doesn't know how to add two dogs together because that doesn't really make sense for Python's sake. In this case, we added this add Dunder method, which basically lets us take advantage of this plus operator, which invokes the add Dunder method. So if I do this correctly, rover does not get a name by default. So I just create a new dog with no name, because again, not all dogs or not all puppies will be named rover. So I could unsign it later, rover, and then print rover. All right, so hopefully it's clear what's going on here. So this plus operator, I've custom defined it. This is my class. I can kind of do whatever I want. Usually you want to do something sensible. In this case, I could create like a make puppy method on dog instead of using the plus operator, but I just kind of want to highlight Dunder methods. So I'm overriding the default plus operator. And in this case, just making a new puppy. So two dogs get together and make a puppy. I'll leave biology class to explain that one if there's questions there. But so let's clear this and run this. And I got an error, which is not good. Puppy class not defined. I made a mistake. Definitely happens to the best of us. So puppy class is not defined. Does anyone spot the error quickly? All right, so hopefully you guys spotted it. But the issue here is I'm not using self. So self, again, is the instance, and that is referring to the puppy class. I can't just have a puppy class like this. If I wanted to, I could use dog here, because puppy class is a class attribute. However, if in the future I wanted to override puppy class on like a particular instance, this would not catch it. This would always reference the class attribute. But maybe I have a special puppy class that I create in the future that I want to assign to my dog class, so or dog instance. So in this case, I'm going to use self. So self's going to search for a puppy class member on the instance, but in this case, we've not defined an instance attribute. So this will fall back to the class attribute. All right, so hopefully that fixed my error. We'll run this. All right, so we get rover. Rover is a dog who has 4 legs, 2 eyes, and a tail. Again, that's coming from the string method. If you wanted to create a special puppy string Dunder method, we could do that also. We'd say def string, and then write a special description for a puppy. In this case, I don't know what would be special about a puppy or a dog, so I'm just gonna fall back to the dog description. Because a puppy is a dog, it's just a special kind of dog. All right, so again, this is I want to kind of highlight what classes can do. They're very extensible. They could be customized. Again, creating a custom add Dunder method to kind of produce a puppy when I add 2 dogs together. Again, we can make this more complicated. I'm not going to get too involved here, but like our add might want to check like, hey, that these dogs are male and female, for example, or we want to check if they're neutered. If they're neutered, we don't want to return a puppy from this operation. Again, that's more real world. I'm not going to go through adding those attributes, but again, if you want to create like a a simulation with dogs, you might add those attributes to your dog class. Another thing I might do here, like right now, I'm assuming that a dog gets passed here. Like, what if I had a cat object? I could check if this is actually a dog object. So one method I want to highlight, because it's useful with classes, is the is instance method. So is instance checks if a given object is related to a class. So if I do if other dog, and And then I'm going to pass a class. So basically this is saying, is other dog of type dog? So in this case, if that's true, I already know that self is a dog because I'm already in my dog class. So I don't really have to bother about checking self as being a dog. So is instance other dog, have my colon, put these parentheses, I'll return puppy. Else, if it's a cat, then I don't think dogs and cats can get together, so I'm going to return none. All right, or I can raise an error. We haven't talked about error handling. That's another topic. I don't want to introduce too many new topics here. But in this case, if the other instance is a dog, return a puppy, else return none. All right. So, let's say I had a cat class. Just to save some time, I'm just going to create my cat class and my dog class. Bad practice, don't do this. But let's call a cat class, and cat class has nothing in it. All right. All right, bad practice, don't do this, but I'm doing it right now to save time. So I create a cat class, import that, and let's create a new cat, Garfield equal cat, and Garfield cat's name. So in this case, I created Rover, but let's say I want to do, another puppy. What's a good puppy name? I don't know, Scrappy. Equals Fido plus Garfield. All right, so in this case, if I, since I added this is instant method, other dog is not actually going to be a dog class. So this will fail if I pass in a cat object, because cat and dog have no association. So if I do this, let's print out Scrappy and see what Scrappy is. So clear this and give that a run. Where's? Got an error because Garfield doesn't actually take the name. So my cat class takes in no parameters, so that's why that was failing. All right, so I gave this a run. Garfield is a cat, so when I do Fido plus Garfield, I actually get a none result. So ideally, if I were doing this properly, I would want to check that Rover is none also. But in this case, I know Fida and Fido are going to produce puppy, so I didn't check that. But to be clear, I will want to do if Rover is not none, then I would want to do this logic. Otherwise, if I tried to access rover.name and rover didn't exist, I would get an error. So to be correct here, you want to check if this is not guaranteed to produce puppy, then you need to check if it's none before using it. Again, a little more advanced. If you have questions, don't worry. We're going to go over inheritance and you get more familiar with Dunder methods, but just want to showcase, again, some features of classes. Again, is instance is very useful. There's also one called is subclass that you can use in case you have derived classes and want to know if it's a derived class or not. Yeah, so that's a general overview of classes. Kind of just wrap up the lecture here, if I can find it. All right, so key takeaways. A lot to take away here. Some of the topics, again, we'll talk more about inheritance and other aspects of object-oriented programming in future lectures. But on the base level, I want you guys to know what object-oriented programming is. And just to recap, that's creating classes or concepts and then creating objects from them. So the terminology that you want to nail down here is classes are blueprints, and then instances are actually when you create objects from classes. So like Fido, Fida, Rover, those are instances versus dog or cat or puppy, those are classes. Again, know what classes are used for. Again, as I said, they're really useful for modeling real world objects. And that's where they're kind of intuitive, and you find object-oriented programming all over places because usually you're dealing with real world objects or creating objects that have attributes and methods that want to work together. Hopefully you guys know how to create a class in Python. Again, pretty straightforward. You use the class keyword, give your class a name. Don't forget that colon. I always seem to forget the colon when I'm writing if statements for classes. Know the difference between a class and an instance. Again, we've recapped that, but it's good to nail down. So reiterate, classes are concepts, instances are objects. And then class attributes and instance attributes. We've talked about that in some detail, but again, class attributes are generic attributes that apply to all future instances of the class. So again, for dogs, generally, most dogs have four legs, 2 eyes, 1 tail, but there are exceptions, so you can override that. With instant attributes, those are more individual specifics, like dogs have unique names. They might know unique tricks. We actually didn't use the tricks. I guess there's one more thing I want to show you, just to wrap up here. So we didn't use that tricks parameter, but I want to kind of show you maybe how they might be useful. So let's go to, let's give Fido some tricks. Let's say he knows how to roll over, and he can also play dead. Those are his tricks. And then Fida has maybe some more skills. She can also play dead, but she could shake, and then she could also, let's say, I don't know, jump high. I don't know if that's a trick, but we'll just pretend it is. So I actually created a set here, not a list, and that was purposeful. So I'm going to change this to a set. And this will be the last example, I promise. We're going to get to our 11 o'clock set. All right, so that's a set. The reason I wanted to do this is because I want to kind of show off sets to you guys. So let's say this takes in a set. Tricks set equals, so now we have two parents, so we can do self dot tricks, and then we could actually OR it. So this is something useful about sets. You can kind of combine them. So if I do other dog dot sets, it's actually going to combine their trick sets, but since they're sets, they're going to be unique. So I have trick set, and then I want to pass in tricks sets. All right, why is this being highlighted? All right, that's there. Go to puppy. Well, now we need an init method because puppy's taking in a value. Actually, we don't, because our dog. Right. Puppy class can just use our dog init method, which takes in a name and trick set. And if I did this all correctly, Rover should have some tricks. So if I print Rover trick set, all right, fingers crossed that I didn't make a mistake. All right, so we look at the tricks. We have rollover, shake, jump high, and play dead. If you notice that both Fido and Fida know how to play dead, but since this is a set, and we talked about sets last week, just wanted to show an example of where sets can be handy. In this case, we combine both these sets, but the duplicates got removed out. So in this case, there's only one play dead trick. Like, Rover is not going to have multiple play dead tricks because that wouldn't really make sense. All right, so that's just another, example of using the add Dunder method, using set. Again, maybe too complicated for our use case right now. But to wrap up, key takeaways, again, hopefully you guys are comfortable with sets or with classes. You're going to be using them for the challenges today. Let's kind of go over the challenges and then maybe just give a high-level overview of the week ahead, and then we'll take a break and then get into our discussion groups. So our challenges for today, there are two. Guessing game, let's take a quick look at that. Again, the discussion groups might go more into detail. This is a simple guessing game where maybe you play this as kids, maybe you play as adults, I'm not sure. But basically, one person has a number in mind, and you got to guess it. And let's say, I have a number, and you give me a guess. I'll say higher or lower to kind of help you narrow it down. So this guessing game will take in inputs, and you'll have a target number. So if the guesser guesses something that's too low, you'll say higher, as in signaling the target number is higher, and vice versa. If they guess too high, you're going to say lower. If they get the correct guess, you'll output correct from your solution. All right, so we have some driver code for you, so just take a look at that. The other one that I definitely want to focus on, because I would say this is one of my favorite challenges from the entire program, is the Boggle challenge. I'm not sure if you guys have played Boggle. It's kind of an older word game or a board game. This challenge I love a lot, so I'm gonna rep it. We have a basic challenge where you want to simulate a Boggle board. And then also you're gonna create some dice. Again, Boggle, if you're not familiar with it, you have a board of random letters and you need to find words within it in a certain time limit. There's some edge cases, like a Q case. Again, you guys can read this over. The only reason I wanted to highlight this is because there's a challenging part, stretch goal, Boggle part 2. I don't have the power to do this, but I'm just gonna say this. Attempt this challenge. It's really enjoyable. It's great problem solving. Again, even if you don't complete it, I want you all to attempt it and just to give it your best shot. Boggle part 2 actually involves searching for words within your board. So again, this is not trivial. So don't feel bad if either you don't complete it or it takes you a while to complete it. Basically, once you have that Boggle board, you got to be able to search it, and that's not a trivial operation where you can just say find, right? You're gonna have to create a real algorithm for searching a physical Boggle board. Again, like you can't just keep searching a line because the Boggle board is a square board with I think 4x4 letters, and you could go diagonal, you could go adjacent, So it's a great challenge. Again, I really enjoyed it. So I hope all of you guys will at least attempt the stretch goal, even if you guys don't solve it. So that's my, I guess, plug there. Hope you guys enjoy that challenge as much as I did. Just looking at the rest of the week, give you just a highlight so you guys know
Hey,
what's.
Ankur, do you want to stop the recording before?
Sure.
No, you're good.
Sorry about that.